Okay, so this is Kinematics Part 3. We'll start out with a little review here, and then we'll do some new stuff right here. Okay, so average speed. If we want to get an average speed, we take a distance and we divide by a time. We have that in our notes in Part 1. Okay, average velocity, we got to attach a direction to that. The calculation for average velocity is delta x over t, change in position over time. So we would use the displacement to do that. Okay, now that doesn't account for the direction. You have to know what that is somehow. You have to be given information to be able to get the direction. Another way to get an average velocity is to take a v initial and a v final, add them together, and divide by 2. Okay, so this is not delta v over t. This is not what we did down or for acceleration. We'll do that in a second. This is, let's say there's a car, it's going 10 meters per second, and then it sped up to 20. Okay, and we wanted to know the average velocity just for that information. We don't have any time or anything like that. Okay, it was going 10 and then it was going 20. What's the average? We do 10 plus 20 is 30. We divide by 2 and we get an average of 15. Okay, sometimes we might need that. This we won't use that much. Okay, what do these equations have in common? No acceleration. And let's add this. Okay, the thing might actually be accelerating, but we don't deal with it in these equations. Okay, we're just dealing with distance, time, and speed, and velocity. Okay, so acceleration comes into play down here. We learned in Part 2 that it's equal to delta v over t. And this is still all review. We also learned we can write it like this. Well, actually, I'm going to just rewrite it. And we dealt with 5 examples with the motorcycle. Okay, go ahead, use your algebra skills. Flex your algebra muscles and solve that for v final. Solve this equation so it says vf equals. Take a second and do that. Getting v final by itself. Before I deal with this right here, I got to multiply the t to the other side. Okay, so I have at equals vf minus vi. That's step 1. I can't do anything with the vi till I move that. Now I just simply add that to the other side. I'm going to put vf on the left because that's how we do equations. The thing that we solve for is on the left. And all I do is add that over there. And I'm going to put it in this arrangement, vi plus at. Take out your equations page that you have for quizzes and tests and whatnot. See if you can find this equation. We need to know that resource well, so see if you can find that on there. What we need to realize is that this and this are the same thing. This is just called the basic acceleration equation definition, okay? All right, they're just solved for different things. A lot of times we'll want the final velocity. In the motorcycle examples, what were we solving for? Every time, we did 5 of them. We were solving for that, so we used it in this format, okay? We rearrange it. Sometimes we'll want to know the final speed of something, and sometimes we might want to know the time, okay? But this is how it shows up on your equations page and in books and stuff. Yep, so question?
For the motorcycle thing, if you didn't give us the, like, if it was like 150 to 200 and you didn't give us the 200, could we find it with just, and you gave us the acceleration?
Yes, you could find the VF or the VI if you had these other things and one of the speeds, okay? We're going to use it to find lots of stuff. Now, you might notice in here when we're dealing with acceleration, there's no distance in there. There's no delta x dealt with in this scenario. We need another layer of math to be able to deal with that, okay? And that's what we're going to do right now. So we are going to prove another one of the kinematic equations. We're going to prove that it works. And we are going to use a bunch of awesome math skills. So let's say we have a scenario where we have something speeding up. And we're going to say this is VI. And then up here, it's going up to some V final. And for this example, this thing is not starting from rest. Down here, some time is going to go by. I'm going to divide this area up into 2 shapes. Okay, and we're going to call this A1. We're going to call this A2. Things we already know. The slope of this line gives what? Acceleration. Okay, and it turns out the area under this graph is going to give us the displacement, or the meters traveled. And we're going to prove that here in a second, okay? So area, and I mean the total area, gives delta x. And this, by the way, is just a little bit of basic calculus. You guys are doing calculus today. Okay? Now you're not going to need full-on calculus for this class. Okay? But this is the start of it. Alright. So how do we get this area here, and why does it give meters? That's what we're going to prove right now. So we're going to start out by saying delta x equals A1 plus A2. And we have 2 different shapes. Okay, what is A1? How do I get the shape of a rectangle? Anybody? Base times height. Okay, so I've got a base and I got a height. More on that in a second. Up here I got a triangle. A triangle, a right triangle is half of a rectangle, right? Okay, so all we do over here is 1/2 the base of the triangle times the height. Okay, now off to the side, here's how we kind of prove the meters thing. Okay, the base of this is measured in what? It's seconds. Okay, the height of this is measured in meters per second. Okay, speed, time. Okay, now if I want an area, all right, I can do A1 equals meters per second times seconds. I did a height times base, but just a different order. Okay, now that cancels down to meters, right? Okay, in calculus they call that an integral. Okay, base is time, is what we just learned. Height. If I go over here, the height of this rectangle is my V initial for my car, or whatever it is that's moving. The 1/2, we're going to leave it alone. It's a constant. Okay, the base of this triangle right here, what is it measured in? It's still a time, so we're going to call it T. And the height gets a little complicated, because the height of this triangle is right here. So what I have to do is I have to say the height is V final, but I got to subtract this part out down here. So I get V final minus V initial for my height. Okay, any questions on that part so far? This is just subbing things in from my graph. We're building an equation from scratch. Any part of that not make sense? Okay, we're going to do 2 more lines of algebra here to prove this. The first thing we're going to do is we're going to rearrange this so it says VIT, because that's the order most textbooks write that in. So we're just going to switch that. It doesn't change anything. Okay, then we're going to go 1/2 T. And we're going to get rid of V final. Okay, a lot of times we won't know the final velocity of it. There's a way to get rid of it, because in this equation, look, I have 1, 2, 3, 4 variables in here. Okay, we're gonna get rid of some stuff. So if I go up and look at this, can we use a different color? Okay, I've got that right there. I can take it and I can put it right there in place of V final. What do they call that in algebra and math? Substitution. That's right. It's a replacement of one thing for some other stuff. Okay, and it's going to look kind of ugly here for a second. But we're going to clean it up. So we get VI plus AT minus VI so what I did was I just subbed that in for V final, but I can't forget that I still have this VI. It doesn't go away. It didn't get subbed out. Okay, so it's still there. All right, now look at this. I got a negative and a positive in the same addition problem, so we can just cross them out. We love canceling variables in physics. And here's our final product. We got VIT plus, and what I have to do is multiply this times AT. So what happens is we have the 1/2. It just kind of stays. The acceleration looks like that. And then T times T. What do? Oh my gosh, we got a quadratic. Okay, we got T squared. And that is a brand new sparkly, shiny physics equation for you. Okay, put a box around it. It is in that format on your equations page. Okay, now what we remember here, this is just an area calculation. That's all it is it calculates the area under this graph. Okay, now some cool stuff with it. Let's say we have a car that is starting from rest. Its VT graph would look like this. Okay, what's the initial velocity? VI equals 0. Okay, that's this little point down here. All right, now I just have a triangle here. If we look at this equation right here, this was 0, so what does the equation become? It's just this triangle equation. So we have for right here, delta x equals 1/2 at squared. The VIT went away. We will use it in that format a lot. Okay? Now, you're not going to have to do this proof on a test for me. Okay? But I do like you to know where your equations come from. Could I just slap that equation on the page and say, hey, here it is, use it? Could I have done that? That wouldn't have been very nice, though, would it? You guys would have been like, come on, Mr. Hicks, prove it. Where did it cut? That's what you guys would have said, right? You would have been fine if we skipped that and I just slapped it on the page. Okay, I like you to know where these things come from. Okay, so we talked about where that comes from. Definition of acceleration. If we want meters, we got to know the area under a graph. Okay?